So, we've learned how to calculate the average atomic mass. We've learned that atoms have different isotopes that have different masses because they have different numbers of neutrons. But now we're really going to take a second to look at the masses on the periodic table and what they mean. Because we can see that all of these masses are averages, okay? The mass of vanadium is 50.94, chromium 52, manganese 54.94. Those are all of our weighted averages, okay? So what we're going to look at is what do those numbers really mean? And realistically, it's the mass of 1 mole of an element, okay? So we use this word a lot because it has a bunch of different uses in chemistry. So the mass of 1 mole of a specific element. So I can tell you by looking at a periodic table that 1 mole of nitrogen has a mass of 14.01 grams. Now it's important that I put the ends on both of these because it's different for every element. So 1 mole of 1 mole of nitrogen has a mass of 14.01 grams, but 1 mole of neon has a mass of 20.18 grams. What I can also tell you is that 1 mole that has a mass of 14.01 grams contains 6.022 times 10 to the 23rd nitrogen atoms. And if I were to go so far to say, like, okay, well, how much space does that take up? Well, that takes up 22.4 liters of space at STP. Now, if we're not at standard temperature and pressure, that might be a different volume. But right now, we're pretending everything's at STP. So 1 mole of nitrogen atoms, which is 6.022 times 10 to the 23rd nitrogen atoms, takes up 22.4 liters of space and has a mass of 14.0 grams. Now, these masses are all based on carbon-12. So 1 AMU, or atomic mass unit, is 1/12 of the mass of a carbon-12 atom. Now, because that's all based on carbon, 12 grams of carbon-12 have 6.022 times 10 to the 23rd atoms. Now, if we look at the periodic table, we can see that a regular carbon, or a regular sample of carbon, if we had 1 mole of carbon atoms, we would have 12.01 grams. And that is because it would have that mixture of carbon-12, carbon-13, and carbon-14. Now, what do we use this for? Well, if we are doing mole conversions, I know you're all so excited to do some more dimensional analysis, okay? We might ask a question like, how many grams of nitrogen are there in 4 moles of nitrogen? So just like we've been doing before, we take our 4 moles of nitrogen and 1 mole of nitrogen is equal to 14.01 grams of nitrogen. So we'd multiply our two numbers together, and we'd find out that 4 moles of nitrogen has a mass of 56.04 grams. Now, sometimes those problems aren't as simple. Sometimes we add a few extra steps. I know, everything I do adds extra steps. I'm sorry. But if I were to ask you how many atoms are in a 6-gram sample of neon. Well, we got to do a little bit more work for this. So we look at our periodic tables, and we see that neon has a mass of 20.18 grams per mole. So 1 mole of neon is 20.18 grams of neon. So we're going to use that, and we're going to use that 1 mole equals 6.022 times 10 to the 23rd atoms in order to find our answer. So we start with our 6 grams of neon. Now, there's 20.18 grams. In 1 mole of any. And 1 mole of any element, but I'm just going to keep it Ne, is 6.022 times 10 to the 23rd atoms. So you can see your grams cancel, your moles cancel, and I'm left with my answer in atoms. So once again, we're going to multiply across the top, divide by what's on the bottom, and then multiply what's on the top again in order to get our answer. So quick refresher again, because I know a lot of you are still using your phone calculators when you do these problems. We have 6 times 1 divided by 20.18 times 6.022. Hit that E button. It's going to become your friend. 23 divided by 1, and we get our answer of 1.79 times 10 to the 23 neon atoms. Good luck!